Welcome to new session of the differential equation. In this session, we will discuss about the integrating factors. As we all know, in the previous two sessions, we discussed about the exact differential equation. That is, if a differential equation of the form m of xy dx plus n of xy dy is equal to 0 is a differential equation if dou m divided by dou y is equal to dou n divided by dou x, then we say that the equation 1 is exact differential equation, is the exact differential equation. And also we discussed it is that how we will solve this exact differential equation. See, we have used two methods to solve this exact differential equation. So we will solve the exact differential equation by using the method u of xy is equal to integral of m of xy dx plus some g of y is there. After finding these values, again we will differentiate u of xy partially with respect to y. So we will find dou u divided by dou y. This we can dou u divided by dou y. This we can equate with n. After equating u of xy with dou u by dou y is equal to n, we can find out the value of g dash of y. The value of g dash of y. The function g dash of y will exist. After getting this function g dash of y by the integration, we will get the value of g of y. We will get the function g of y. Okay, this is the method that we used lastly. And also we have one more method is that is the general solution is integral of m of xy dx plus integral of terms in n, all the terms in n which are not involving x into dy is equal to c. So by evaluating these integrations, we will get the general solution of the given differential equation. These are the two methods that we use to find the general solution of the exact differential equation. That is possible only when dou m divided by dou y is equal to dou n divided by dou x, or simply my is equal to nx. Okay, this is my is dou m by dou y, nx is dou n by dou x. Okay, so in this lecture our thought is that how we will solve a differential equation m dx plus n dy, a differential equation of the form m dx plus n dy is equal to 0 even if it is not exact differential equation. So our first thought is that how can we make it is exact? So by multiplying integrating factor. So that is our thought, it is that how we will find the integrating factor of a differential equation. So this is the method. So the integrating factor can find as a function in x or can find as a function in y. And suppose this is integrating factor is equal to h of x is equal to my means dou m divided by dou y minus nx divided by n. We can find the integrating factor by using the formula integrating factor is equal to e raised to integral h of x dx. Simply I would like to write, instead of this is integrating factor as just a minute, integrating factor can be written as this is equal to integrating factor can be written as a function sum u of x. Okay, sum u of x. I would like to say sum u1 of x. And similarly, maybe function in y, this is equal to g of y is equal to, that is nx minus my, that is dou n divided by dou x minus dou m divided by dou y divided by m. this is the integrating factor is equal to e raised to integral of g of y dy. Maybe we can use this as some mu 2 of y. Okay. So, we can multiply the integrating factor on both sides of the equation number 1, that is our this equation, that is the m dx, that is mu 1 of x into m of xy dx plus mu 2 of x, sorry, the same function mu 1 of x into n of xy dy is equal to 0. Okay. If you multiply this, your new value, that is the maybe can be written as this is some p, that is p of xy. Okay. This is some q of xy. This is the function, this is the differential equation. This is the differential equation that we discussed before, as we discussed this as m, as we discussed this as n. So, instead of that we have here p is there, also q is there. So, this can be written as, this is I would like to say this is equation number 2. The equation number 2 is generated from, developed from the equation number 1, because the equation number 1 is not an exact differential equation. Since it is a non-exact differential equation, our thought it is that how can we make that as an exact differential equation? For that we found this integrating factor. Now, this is a new differential equation like p of xy dx plus q of xy dy is equal to 0. This is an equivalent differential equation of 2. So, I would like to say this is equation number 3. Now, this is this equation as same as the equation m dx plus n dy is equal to 0. To say 3 is exact, to prove 3 is exact, it is enough to say that dou p divided by dou y is equal to dou q divided by dou x. Then we say equation 3 is exact differential equation. Then we say equation 3 is an exact differential equation. See, my dear students, if 3 is exact differential equation, you can solve 3. By solving 3, you will get the solution of 2. The solution of 2 is actually the solution of equation number 1. Okay. So, this is the method to find the integrating factor as like this. Either you can find a function h of x as my minus nx divided by n. You can find the integrating factor mu 1 of x is equal to e raised to integral h of x, that is this value dx, and also g of y is equal to nx minus my divided by m. You can find the integrating factor e raised to integral of g of y dy. After finding the integrating factor, we will multiply that integrating factor in both the sides of the equation number 1 m dx plus n dy is equal to 0, but actually the right hand side is also always 0, the right hand side is will be remains as a 0. Okay, dear students, we can move to questions. Write down a question. The question number 1, solve the differential equation, solve the differential equation y square minus x dx, y square minus x dx plus 2y dy is equal to 0, plus 2y dy is equal to 0. This is equation number 1. See, my dear students, our question is that y square minus x dx plus 2y dy is equal to 0. See here, as we discussed before, we can say that this y square minus x is m, this 2y is n. Okay, fine. We can evaluate dou m divided by dou y. M is equal to y square minus x and n is equal to 2y. Okay. So, we can evaluate dou m divided by dou y, that is my. Dou m divided by dou y, or simply we can find my. My is equal to derivative of y square, that is equal to 2y. We are differentiating with respect to y. Minus x, the derivative of minus y, we are differentiating partially with respect to y. That is why minus x derivative of minus x is equal to 0, and dou n divided by dou x, okay, that is equal to, this is actually nx, nx is equal to dou n divided by dou x. See, my dear students, this is dou n by dou x, there is no term containing x, that is why we can say that this is equal to 0. So, simply dou m by dou y is equal to 2y and dou n by dou x is equal to 0. Therefore, we can say that dou m divided by dou y not equal to dou n divided by dou x. Okay. So, that we can say that the equation 1 is not exact, the given differential equation is not exact. Therefore, we can say that given differential equation 1 is not exact. So, we are unable to solve by the methods that we discussed just before. So, now we have to solve this differential equation. For that, we will solve by finding the integrating factor. So, we can find to find integrating factor. So, what we will do to find integrating factor? My dear students, you may listen here. To find integrating factor, what we done it is there h of x. H of x is equal to my minus nx divided by n. H of x is equal to my minus nx divided by n. So, my dear students, to find integrating factor, we have h of x is equal to my minus nx divided by n is there. My minus nx my minus nx divided by n is there. Fine. Sorry. Okay. So, we can write this is equal to, we have to find h of x, we can evaluate this is equal to my is there, that we already found, that is equal to my is equal to, what is my, that is 2y, and nx is equal to 0 divided by n is there, n is actually 2y. So, we can write here as my is equal to 2y minus nx is equal to 0 divided by 2y. So, this is actually 2y divided by 2y, that is equal to 1. So, the value will be equal to 1, okay, that is equal to 1, the value 1 is there. So, find h of x is equal to 1 is there. So, actually what is integrating factor? Therefore, integrating factor mu of x is equal to e raised to integral h of x dx, e raised to integral h of x dx. See, my dear students, e raised to integral h of x dx, h of x is actually 1. So, we can say this is equal to, that is mu of x is equal to e raised to integral 1 dx, that is equal to e raised to integral 1 dx is e raised to x. This is mu of x is the integrating factor. Okay, fine, we found integrating factor. The next step is that we have to multiply integrating factor with the differential equation 1. So, multiply both sides of equation 1 with the integrating factor mu of x, with integrating factor mu of x, okay, with integrating factor mu of x. We can multiply both sides of our equation with the integrating factor mu of x. So, actually our equation 1 it is that y square minus x into dx. So, we can write this as e raised to x into, so we can write e raised to x into y square minus x dx, okay. Then the next one is that the second term, that is equal to 2y dy, 2 e raised to x y, 2y e raised to x. So, this is equal to plus 2y e raised to x dy is equal to 0. Okay, fine. Now, you may check it is actually this is equal to y square e raised to x minus x e raised to x dx plus 2y e raised to x dy is equal to 0. This is the new equation. I would like to put it as equation number 2. Fine. As we just discussed, here it is, this is P and this is Q. As we discussed before, instead of M, here we just used P, and instead of N, we just used Q. Have to find dou P divided by dou Y, that is equal to Py, dou P divided by dou Y, this is equal to, this is P. Derivative of P with respect to Y, that is equal to y square is there, therefore 2y e raised to x is there. The x e raised to x contain the term containing only x. As because we are differentiating partially with respect to y, this we will treat as a constant, that will be 0. So, the remaining portion is 0. Now, we have to find dou q divided by dou x. See, my dear students, the q is 2y e raised to x is there. While evaluating dou q divided by dou x, the value is equal to 2y, the derivative of e raised to x, the derivative of e raised to x is actually e raised to x. See, my dear students, here dou p divided by dou y is equal to dou q divided by dou x. Therefore, we can say this is equal to, here dou p divided by dou y is equal to dou q divided by dou x. Hence, what we can say, the equation 2 is exact. So, we can say that the equation 2 is exact. Therefore, equation 2 is exact differential equation, is an exact differential equation. So, my dear students, just come back to here. Here we have y square e raised to x minus x e raised to x is equal to 2y e raised to x dy. So, instead of n, here we have q. Instead of m, here we have p. So, my dear students, I would like to start as u of x y as, see, therefore, u of x y is equal to integral of, see, my dear students, integral of n of x y dy, that is equal to q of x y dy is equal to q of x y dy plus this we used as dy, therefore, the constant of integration is g of x is there. Fine, my dear students, we can write this is equal to integral of q of x y. What about q of x y? 2y e raised to x dy, 2y, therefore, this is equal to 2y e raised to x dy plus g of x is there. Okay, fine. So, we can write this as this is equal to the term we can write this as integral of 2y e raised to x is equal to 2y square by 2 into e raised to x plus g of x is there. This is u of x y. This is u of x y. Okay. So, we can cancel this 2 and 2. Finally, we will have u of x y is the general solution, y square e raised to x plus g of x is there, y square e raised to x plus g of x is there. Okay, is the general solution of the differential equation. So, I would like to put this is as equation number 3 is the general solution of equation, and here we need to find g of x. So, u of x y, that is u of x y is the general solution, is the general solution. We have to find the g of x. We have to find the g of x. So, dear students, as we discussed before, we can say that this is dou p by dou y is equal to dou q by dou x, and here we used it is equal to this one. Here we used it is equal to this one, u of x y is equal to q of x y dy plus g of x. Therefore, we can say that u x dou u by dou x is equal to dou u by dou x is equal to, we can say that this is equal to, we formerly used m, instead of m here we have p. We formerly used m, here we used instead of m, here we used the letter p, p of x y. So, this is equal to, we can write this is equal to p of x y. Okay. From equation number 3 we can say that dou u by dou x, that is dou u by dou x equal to y square e raised to x. Dou u by dou x is equal to y square e raised to x, derivative of e raised to x is equal to e raised to x plus g of x, derivative of g of x. G of x is a function of x alone. Therefore, partial differentiation of g of x is actually g dash of x. This is equal to p of x y. So, actually we can say that this implies y square e raised to x plus g dash of x is equal to the p of x y is actually y square e raised to x minus x e raised to x. So, y square e raised to x, y square e raised to x minus x e raised to x, y square e raised to x minus x e raised to x. So, dear friends, we can cancel y square e raised to x from the LHS and y square e raised to x from RHS, and finally, we will have g dash of x is equal to, finally we will have g dash of x is equal to minus x e raised to x. G dash of x is equal to minus x e raised to x is there. Okay, fine. Now, have to find the g from here. How can we find g from here? That is our question. So, by integrating we can find it. Therefore, integral of g dash of x dx is equal to integral of minus x into e raised to x dx is there. Okay. So, we can write this is equal to integral of g dash of x is equal to some g of x is there. So, minus x into derivative of e raised to x is e raised to x plus e raised to x into derivative of minus x is minus 1, sorry, into minus 1 is there, okay, plus the constant of integration is there. So, I would like to write this is equal to some plus C1 is here. Okay. So, we can say that g of x is equal to minus x e raised to x minus e raised to x is there plus some C1 is there, minus x e raised to x, okay, minus x e raised to x into, okay, minus x into derivative of e raised to x, okay, fine, minus e raised to x plus C1 is there. Fine, we can apply. Put in 3. We can go back to equation number 3. See in equation number 3 u of x y is equal to y square e raised to x plus g of x. So, we will have u of x y is equal to, therefore, the general solution is, we can say, therefore, the general solution is we can say that the general solution is y square e raised to x, the general y square e raised to x plus g of x, y square e raised to x, sorry, general solution is y square e raised to x, the u of x y is equal to, sorry, u of x y is equal to y square e raised to x plus g of x y. So, actually g of x y is equal to, sorry, g of x is equal to minus x e raised to x minus e raised to x plus c1, minus x e raised to x minus x e raised to x minus e raised to x plus c1. Okay. So, we can say that that is equal to c. Well, as we done before, we can say that that is y square e raised to x minus x e raised to x minus e raised to x equal to c is the general solution. Maybe we can write this as, we can take e raised to x is equal to outside, therefore, we can write this is equal to y square minus x minus 1 is equal to c. Can take e raised to x maybe to here. for the beauty, we can write this as, see my dear students, we can write this is equal to, sorry, y square minus x minus 1 is equal to, sorry, c e raised to minus x is the beautiful general solution of the given differential equation 1. So, this is the general solution of the given differential equation. See my dear students, what we done here it is that you may think about it is that actually maybe the differential equation has a thing is that that may be the differential equation m dx plus n dy. While evaluating my, that is dou m by dou y and dou n by dou x, dou m by dou y is equal to 2y and dou n by dou x equal to 0, and from here we understood it is that they are not equal, that is my not equal to nx, that means the differential equation is not exact. So, that we have to find the integrating factor. So, for finding integrating factor we have the formula h of x is equal to my minus nx divided by n. While evaluating that one, we will we got h of x is equal to 1. Therefore, the integrating factor is mu of x equal to e raised to integral h of x. So, we found mu of x as integrating factor as e of x. So, we will multiply both sides with integrating factor. So, we got a differential equation p of x y dx plus q of x y dy is equal to 0. That is differential equation equivalence to differential equation 1, even though the equation 2 is exact because py is equal to qx. Okay. So, naturally we can solve how we solved before it is. So, this is the method of finding integrating factor. You can find any integrating factor, no problem, but the thing is that while taking the integrating factor, we would like to choose the easy part of that. Maybe some p of x y may be easy part, or q of x y may be smaller part of the function. So, which is the smallest smaller type of the function to handle with it is, if we use such one for finding u of x y, that is very easy to us to solve this problem. Okay. Write down some questions as assignments. First one, solve the differential equation, 3xy plus y square dx, 3xy plus y square dx plus x square plus xy dy, x square plus xy dy is equal to 0. See, while seeing this differential equation 3xy, this is m, while evaluating my is equal to 3x plus 2y, but while evaluating this is equal to dou n by dou x, 2x plus y is there, but they are not equal. Okay. So, they are not equal, therefore, not exact, have to find the integrating factor and then multiply with this equation. After we will get a new differential equation of the form m dx plus n dy equal to 0 or p dx plus q dy equal to 0. Then you can solve as we done before. Alright, and one more question, solve the differential equation, x dy minus y dx, x dy minus y dx is equal to 0, x dy minus y dx is equal to 0. Okay. So, that is all. This is a very nice part of a exact differential equation. So, maybe some of the differential equation are not exact, even though can solve by finding integrating factors that we discussed here. You may try to work out more problems on this part, that will be leads to very wonderful parts of a you can enjoy a very wonderful part of a differential equation. Thank you for watching these videos. Continue your watching. Thank you very much.